a finite or an infinite number?
What does it mean to be around an infinite number? Our government is doing a pretty good job of demonstrating that infinity is not defined. The national debt, as I've been sitting here talking to you guys, has increased by $500,000, I'm sure, over the past 2 hours. 17.7 trillion and counting as of 3 weeks ago. I mean, that's a good idea of infinity, right? I mean, technically, because they can just keep printing money. They just keep printing money. There's no cap. Now, there are certain data sets that cap out. And we're going to study one of those when we do exponential growth, not with logs, but exponential growth without logs. If you have a data set that arcs up but then caps off, that's called a logistic behavior of a data set. And that's one of my favorites. Because there are certain things like cancer cells, which are awful, but also many bacteria and good beneficial bacteria that double exponentially. 1 becomes 2, becomes 4, becomes 8, becomes 16. Well, the problem is eventually those things run out of resources, and they can't grow at that rate. Something happens. So they grow at that rate, and then they stabilize. It's doesn't purely head off to infinity. The pure tangent curve does though. Let me grab one of these things. I'll Google a tangent graph, and we can actually watch it. And if I can get one with degrees, that would be badass. We'll try it. Tangent curve degrees. Let's see if I can find one. Hot damn. Yeah, that's decent. That's in radians, that's in radians. Oh, this isn't bad. This isn't bad. This is actually very colorful. Okay, so, it's kind of small too. A lot of this you can ignore. You know what? Let me take a snippet. Let me take a snippet of it. Hang on. We don't need to look at a lot of this. You see, in trigonometry, we talk about rotations of an angle. It doesn't go from 0 to 90. It goes past 90 and it goes before 0. We can ignore that here though, can't we? Snip. Not sunnip. It's a new fun word we're inventing in class. Snip. Ing.
It was there before I
spelled it wrong, it was there?
No, yeah, this is there as a choice.
That's all good. Just over. I'm going to grab this right here, because that's the only part we have to concern ourselves with. Okay. So that's 0 degrees. That's 90 degrees. This is a smooth transition from 0 to 90 degrees. Okay. There's lots of angles in there. 10, 20, 30, 45's in there. 45 would be halfway between, which corresponds to this point in the curve right here, which I cut the scale off, I'm guessing that's 1. So that's the x-axis. The x-axis will be the angle axis, so x equals the angle in this case. Y is the grade in this case. It's the grade. So that's the, if you were to plot all those percentages, it's actually kind of fun. Maybe have you guys create this graph for a quiz. Maybe. No. No? Okay. So anyway, we hated graphs. Okay, we'll come back to it. Maybe not for this one. So this is heading up. This dotted line right here, it's a fun one for Math 1. We'll call it an asymptote. It's a curve that you can never cross. So in other words, it's right at 90 degrees. If the angle can't get to 90 degrees, that means there's no corresponding value on the grade graph that hits that 90 degrees. It gets really, really, really close. That's because you can have the grade of an 89-degree angle, or an 89.1, 89.2, 89.9, 89.99, 89.999. You see how much room there is between that and that? It gets infinitely close. One of the most fun things to talk about in 243 is, how close is close enough? Well, it depends. How close do you want it to be? Go ask that many people, and that gets it as close as you want it to be. So that's the question of tangent. It rockets off infinitely, but it just never gets to infinity because you can't get there. It's an idea, it's a direction. Think of it as a place you're headed. Where are you headed? Infinity. Beyond, like Buzz Lightyear. Yeah. Is that fairish? Fairish-ish? Yeah. Fair. Yeah. It's heady. It's a lot that get hit with at 10 o'clock in the morning. It really is. But at the same time, it's one of the most beautiful ideas in mathematics. And it describes a limitation on the tangent curve, but it's a limitation by definition, and we like it because of that. We like that limitation. Yeah, yeah.
So we need to know how to use x and 9 or TI, whatever.
To do this?
Yeah.
Oh God, no. That's why I taught you tangent tables.
Oh.
That's why I taught you the tangent table, because that way you don't have to use your TI. And you can actually see it, when you look at the tangent table that we were looking at yesterday, images. This one I think the one we're using. Okay, we'll just find another one. There it is, right?
Yep.
Okay.
There's the problem with the government website.
Oh, What's gonna throw up? Let's find another one. Let's find one. I like that one so much. Now, it is saved on your homework page, I think.
What about this one you're there?
How's that one? I want to make, see, that's full of decimals. Not that decimals aren't great, but they are. You know what the hell, let's just do this.
Blow it
There
up.
it
Oh, we
is.
can
There.
see it, yeah.
Is it gonna come into focus? Ish?
Yeah, kind of.
Yeah, it's close enough. Looks better from a distance.
How close is close enough?
Up close.
Good job.
Golf clap, golf clap. Notice how these tangents aren't growing very quickly, and then past the point, they start getting real big, real fast. You're getting a glimpse of infinity right there. And what's cool about that is, that's at 89 degrees. Notice how 90 just got a line through it? Nope, can't do, can't do, can't do. What's fun is, there is an angle that has a grade of 100%. Or, excuse me, 100, which would be 10,000%. There is an angle that has a 20,000% grade. There is an angle that has a 40,000% grade. There's a long way between 57 and what we call infinity. It's one of those crazy things that's hard to wrap your head around. But every number from 57.2899 up towards infinity is on this chart somewhere. It's just not between, it's not literally a perfect integer like 89. It might be 89.99993. But it's on there, they just didn't show it to you. That's where that curve is beautiful. It shows you all of them. But you have to generate the curve. It sounds like you guys don't like them so much. That's okay. We'll come back to it when, we'll warm you up to the idea, because they are very helpful and useful. But that's the thing. There's lots of numbers on this. They're only showing you 91 of them or 90 of them or so. Yeah, Josh.
So do angles greater than 90 have grades?
They do. You have to think about it a different way from the road. Because greater than 90 means you'd be driving upside down on a road, right?
Yeah.
You have to kind of, you can't think of it as a road and a car anymore. That's why I cut that rest of that curve. You can also have below zero.
Like a roller
So would it
coaster?
be a negative
When you go
grade?
upside down?
It can be a negative grade, yes. Negative grades exist. Negative grades exist in your world. If you're going downhill, technically it's a negative grade.
Yes.
Because the rise is negative, you're dropping. Now, the side of the triangle has a positive measure, right, Jessica?
Yeah.
But because you're changing position by going downhill, technically speaking, it's a negative grade. I don't worry about it so much with you guys, because honestly, if you know it's a 4% grade, it depends on whether you're going up or downhill. As long as you know which way you're going, you know what the change is. But mathematically, yeah, did you notice that tangent curve that I had up earlier? How some of the, let me show you real quick. See how the curve exists down here? Those are negative grades. Those guys right there are negative grades. These guys, there's 90 degrees. This is bigger than 90 degrees. Negative grades. Negative grades.
Zero would be like sea level then?
Zero would be, not so much sea level, but flat ground.
Oh, okay.
Flat ground, right. Because, and this is
Not
tricky.
at elevation.
This is tricky. It can be sea level, we're graphing something else, which we will graph it. I like atmospheric changes too. They're fun to model data-wise. But the thing about this is, you have to define what X and Y are. It is a weird thing because you're graphing angle with respect to rise and run. So you're actually looking at three things at once, which is kind of cool. And a little tricky, like I said, at 10 o'clock in the morning. So, fair? You guys making sense? Ish. We're getting there. We're getting ish. So what I'd like to do, I love the questions. I love the infinity idea. That's just so good because it helps understand why does it blow up so fast, right? Why does it blow up so fast? And the simple answer is, I'm envisioning a spreadsheet to build for you guys for your exam, where you can actually take the triangle and pull it and make the triangle change by pulling in the side. That would be kind of fun. It's kind of like a graph. Kind of. Not really though. It's ish like a graph. More like a picture that we're going to try it. I'll try it this weekend. But the idea is that it all hinges on the overarching idea of grade property. Grade property. So what I'm going to do, we have about 10 minutes. I'm going to give you guys this. This is just a blank set of triangles. Everybody take one. I'm going to make more for Monday. Monday, we're going to plan on meeting at Mazama Field instead of up here. We'll come back up here when we're done. We'll spend about 45 down there doing that, and then we'll wander up here.
You do know it's supposed to rain on Monday, right?
Bring your raincoats.
Yeah, brother.
No.
Oh my god.
Bring your raincoats. It's bad. It's not going to rain. It's going to snow. We'll check the weather. If the weather doesn't cooperate, I'll send an email. We'll just meet here.